name is Wilkinson. I belong to the Department of Chemical Pathology, and my research interest is in bioinformatics. I think the most important application is genomic medicine. In our genome, there are many different mutations. Some small number of variants, they actually affect your health. We call them disease-causing mutation. Another application is more on discovery. So for this case, we need to sequence patients with the disease, and then we would like to identify the mutation that appear in multiple patients. So those we will expect they are disease-related. Finally, I think another application is for the drug discovery. In the past, the people try to find drugs from the bacteria or from the fungi. So they will try to extract their protein or the molecule. Now, because we have genomics, we can mine the drug from the genome. They generate many enzymes. And if you know the property of the enzyme, you can guess what are the possible drugs they can produce. Bioinformatics like a puzzle. For example, we work on result on genome assembly. To reconstruct the genome, actually we need to sequence small pieces and put all the small pieces together to generate the whole genome. And every piece is like a puzzle. They are actually very similar. So how can we put the pieces in the correct location is quite difficult. Then finally, we develop a new method. And that method allows us to reconstruct the full genome for every individual. The first example is liver cancer. Actually, most of the liver cancer patients in Hong Kong are caused by HPV. We try to study the genome of those liver cancer patients. Then we identify the HPV actually integrate into our genome. And not only that, if they integrate in certain locations, then they will cause liver cancer. So finally, we do a survey and then we identify this result. And this result helps the researcher and the medical doctor to know what to do. Then the last example is I work with the researchers in Hong Kong Genome Institute. They try to sequence many patients. They have rare disease. And for those patients, we want to identify what are the disease-causing mutations. So using our method, we are able to find some variation in the past cannot find. We help the patient to identify the cause of their disease and so that the medical doctor know how to make treatment. The first thing we want to do is reconstruct the genome. Now, reconstruct the genome is expensive. We would like to reduce the cost so that in the future, everyone can get their own genome. Then from their genome, they can start to understand whether they have any drug resistance. So in fact, this area is called pharmacogenomics. Another use is once you know your genome, then you can try to do some prevention. For example, you may be prone to breast cancer, then you will be able to use your genome to make the prediction. Then you can do some prevention scheme to avoid breast cancer in the future. We would like to develop some method that can identify the disease-causing variant using AI. In this case, we can save the cost and also can ensure many people can find their own disease-causing variant.